Hi student, how are you? Hope you are fine and doing great. Okay student, in the previous video we know about and studied about the Turk. So now in this video we are going to study some parameter or property of the Turk. Mean like when will the Turk is more, when will the Turk is less, or when will the Turk is zero. So in this video we are going to discuss some property of the Turk. Okay, let's see one by one under which what cases the Turk will be zero or more or less. Okay, let's see one by one the parameter or property of the Turk. Okay, the turning effect mean torque produced by the force depend on the three parameter. Normally they write the three, but there are some more properties as well. Here on this page there are three, like the first one, second one and third one. Okay, like this is again the definition. The turning effect of a torque produced by the force, that turn which is produced due to force depend on the three parameter, or it has the three property. Okay, let's see one by one. The magnitude of force. The first one, the magnitude of force. What does it mean? Magnitude of force mean this torque is equal to force multiplied by, mean torque is equal to force multiplied by distance. Like if we increase the distance or if we increase the force, so this mean the first property mean the torque is also increased. Why? Because it is a multiplication property. Like if we increase this one or this one, if we increase the distance or force, like if we increase the let's suppose this is the lever, this is the turning point, like this is turned from this dead point, and we apply the force here 10 Newton, and the same case this is the second lever on the same distance, like 2 meter this one, 2 meter this one, but here we produce the here we apply the 20 Newton force. So in which lever there produce the more torque? Definitely this one. Why? Because we increase the force here. So if we increase the magnitude of force, this mean the torque is also the torque is also increase, or the torque or turn will also be increased because of what? The force or distance as well. Okay, the next one, the distance between the application point of the force and the point around which the object is rotate. Okay, what is the meaning of this one? The distance between the application point. I told you the turning point, like this point, is called application point or turning point. Like in one case there are, let's suppose there are two lever, this one is also 2 meter, this one is also 2 meter. In the first one we apply the force here, and on the second one we apply the force here. This one is also 10 Newton and this one is also 10 Newton. But if we see here the distance between the force and the application point, this is the application or rotation point, this is the force. If we decrease, like if we come close to the application point or turn point, so this mean the torque is also decreased. Or if we move away from the application point or turn point, so the torque is also be more, the turn is also be more. This is the second property. Like the distance between the force and the application point. So if we increase the applied force from the away from the application point, so this mean the turn is also be, or rotate the object will also be easy. Okay, the next one, the angle between the force vector and line connecting to the pivot application point to the force mean theta. Okay, here the one word pivot mean this also. There are some word is used for the rotating point, like the turning point, pivot and so on. So many word is used for this one. So pivot mean turn point. Okay, here let's suppose if we have a lever but we apply the force on which produce some angle, like not exactly on the 90 angle perpendicular, we apply the force not exactly on the perpendicular, like we make some angle theta here. So here it also depend, like remember one thing, only when the force and distance is perpendicular, like this is the distance and this is the force. If there is the angle is 90, so the turn is also be more. But if the angle is decrease from 90 or increase from 90, how mean increase? Like this one, this is the increase and this one is the decrease. So more than 90 and less than 90, the turn is also be effect. Okay, in this case we can use like this formula, T is equal to we will use sine alpha or sine theta dot distance, mean this angle multiplied by this force. So these are the three parameter or property of the torque. Okay, let's move to the next page. We will study more about the torque. Okay, in the last page we study the more increase or decrease of the torque. Okay, in this case we are going to study under what cases the torque will be zero. Look at the first one. The first one, like when the line of forces passes through the axis, the lever arm is zero, so the torque is zero. Look at that. The first one mean when we apply the force exactly like the distance and the force is parallel, like here both are in the same direction, we can say are parallel. So if we apply the force here, but the turning point is on this is the turning point, so this means there will no turn is produced if we apply the force parallel, like when you apply the force on the door, like exactly parallel, not perpendicular on the door or window, so there will no turn is produced in the door. Okay, the next one, like here if we again apply the force on this direction, so again here will be no turn is produced. Okay, here if D is 0, mean the T is what? 0, so here is no distance is counted. The second one is also no distance is counted, we will not count the distance. In the third one, look at here, in the third condition, this is also like if we apply the force on the turning point, exactly here the force, how much more we force applied on the turning point, so in this case also the T or torque will be 0. So the torque will be 0 on three condition. The first one, if the force is 0 or if the distance is 0, this one. In the third one, like in this three property, there will be no distance in this condition, like this is also parallel, this is also anti-parallel, and the third one the force is applied on the exactly application or the turning point, or this one I already draw. So under in this three condition, the torque will be 0. Okay, let's see, this is the simple example. First you will see the angle, what is the torque produced by the force. So very simple, is equal to F multiplied by D. So F is how much? 20 Newton multiplied by 30 meters. So the torque or turn is produced here, 20 multiplied by 30 is how much? I think 600 Newton meter. So this is the simple example. Okay, let's see on the next page. This will be your homework. This too, like simple as that, you will use if you want to find the turn here or torque here, so you use the F sine theta multiplied by distance. So the distance is how much? 0.2, you will put 0.2, sine theta is how much? 37, so the sine theta is also equal to 0.6, and the force is also given, which is equal to 15 Newton. So F is 15 Newton multiplied by sine 37 is 0.6, multiplied this three value, so you will get the T or ta or mean turn. And the other case, find the ta. So in this case, just very simple, ta is equal to F sine theta multiplied by distance. So the distance is also given, which is equal to 2 meter, force is also given, which is 5, and the theta is also given, so this is 5 Newton, and sine 127. You will find sine 127 with the help of calculator multiplied by 2 meter. So if you multiply these three values, so you will get you will find the turn or Turk. So thank you so much, dear students. So this is the some example and some property of the Turk. So hope you find and hope you when you watch the video, hope you will learn something from this video. Okay, thank you so much. If you have any questions, so ask in your comment. Thank you.